Hello students, good morning students. Look at the question GOC question number 46 here, integer question. In the molecular orbital model of benzene, how many pi electrons are delocalized about the ring? The question. You know that already benzene formula C6H6, benzene ring, alternative pi bonds are present. Inside the benzene ring, how many pi electrons are present? 6 pi electrons are present. According to molecular orbital theory, 6 pi electrons are present. The 6 pi electrons delocalized inside the ring. Each carbon contributed with 1 pi electron in that ring. So option integer value is 6 pi electrons. Next question, observe that how many hyperconjugation structures can be drawn for isopropyl cation. Isopropyl cation. Iso means to the carbon chain end second carbon. For example, here the molecule is present like this. To the carbon chain end carbon, methyl is connected. That group is simply called as iso. They mentioned isopropyl cation CH3 CH CH3. This is isopropyl cation. How many hyperconjugation structures are possible? Hyperconjugation, what is the condition? sp2 carbon connected with sp3 carbon, sp3 carbon having hydrogen, that hydrogen involved in the hyperconjugation. Already you know that this is a hyperconjugation. One hyperconjugation structure is possible in this arrangement. Now here how many hydrogens are available? Alpha carbon, alpha hydrogen, alpha carbon, alpha hydrogen. 6 hyperconjugation structures are possible. Next question, observe that next question. There are X plus M groups and Y minus M groups among the following. The value of X minus Y is asking. The value of X minus Y. So X indicates plus M groups. How many plus M groups are present in the given molecule, given groups? How many plus M groups? How to identify plus M groups? First of all, on group which atom, central atom, lone pair of electrons are present, they are act as simply plus M groups. OCH3 lone pair of electron, NH2 having the lone pair of electron, OH having the lone pair of electron, NH having the lone pair of electron, C double bond O CH3. Next, amine, tertiary amine connectivity, it is lone pair of electron, SH lone pair of electron, SCH3 central atom having the lone pair of electron. These groups act as a plus M groups. Next, Y minus M groups. How to identify minus M groups? On which group at central atom double bond or triple bond is present, that bond is connected to the more electronegative element like this. The bond is connected to the more electronegative element, double bond is present here. Aldehyde minus M group, cyanide minus M group. Any other group is there? 1, 2, 3 and pH3 plus, phosphorus having the positive charge. Positive charge, it is nothing but electron deficient. It wants electrons from the benzene ring. Observe here how many plus M groups? 1, 2, 3, 4, 5, 6, 7. How many minus M groups? 1, 2, 3, 4. So 7 minus 4, 3. So answer is 3. And next question. How many of the following generate greater electron density at ortho para position compared to this molecule? How many of the following greater electron density at ortho para position? Ortho para position. Simple example I am giving you. Benzene ring is present. On the benzene ring, OH is present. Benzene ring is present. On the benzene ring, NO2 group is connected. NO2 group is minus M group. We know that. OH group is the plus M group. It releases the electron density to the benzene ring. Minus M groups withdraw electron density from the benzene ring. Here the lone pair of electrons is present. Lone pair of electrons are moving from oxygen to carbon like this. electron density. At ortho position, what is the charge is generating? Arrow mark, observe that negative charge. At para position, what is the charge is generating? Negative charge. Again at ortho position, negative charge is generating. Here, compared to nitrogen, oxygen is the more electronegative element. Electron density moving from nitrogen to oxygen like this. Electron density is moving like this. Withdrawing electron density. At ortho position, positive charge is generating. At para position, positive charge. Para position, positive charge. Ortho position, positive charge. Plus M groups are connected. Plus M groups connected at ortho and meta positions, negative charge increases. Minus M groups connected at ortho and para positions, positive charge increases. Here once, sorry students, here this is para position. So positive charge increases, minus M groups. Negative charge increases, plus M groups. Now observe here, on the benzene ring here, what is the group is present? Tertiary butyl group is present. Tertiary butyl. The tertiary butyl group connectivity is existing like this. CH3, CH3, CH3. Tertiary butyl group only shows plus I effect. Hyperconjugation is not possible to existing by this group because of at this carbon sp3 hybridized carbon hydrogens are absent. This is sp2 carbon. sp2 carbon connected with sp3 carbon. sp3 carbon having hydrogens, hyperconjugation is possible. So here this molecule, this group is not showing the hyperconjugation. Hyperconjugation is absent. Generally electronic effects, dominating effect is, which is the dominating effect? Mesomeric effect is dominating, after that hyperconjugation, then inductive effect. So observe here, CH3, it is showing the hyperconjugation as well as inductive effect. NO2, it is showing minus M effect. NH2, it is showing plus M effect. Aldehyde, it is showing minus M effect. OH, it is showing plus M effect. This is isopropyl. One hydrogen is present. One hydrogen is present means hyperconjugation is possible. So this group is more powerful group. It increases the electron density at ortho para position compared to tertiary butyl because of hyperconjugation is absent. So plus M groups are more ortho para directing groups. Minus M groups are not ortho para directing groups. So 1, 2, 3, 4. Answer is 4. Here the next question, how many of the following are plus M groups? How many of the following are plus M groups? This is plus M group. This is also plus M group. This is also plus M group. This is plus M group. This is minus M group. This is minus M group. This is plus M group. We know that NO2. Why NH3 is a plus M group? Because of nitrogen having the positive charge, it is withdraw electrons from the benzene ring. So 1, 2, 3, 4, 5. Plus M groups are 5 are present. Okay students, bye students. In the next video, we'll discuss new questions.